Okay, now absolute value of x minus 4 less than 6. Interpret this as distance. The distance between what and what is what? Okay? Well, absolute value of x minus 4 is the distance between 4 and x, right? So, which is the same as the distance between x and 4. Absolute value of x minus 4 is the distance between these two numbers. So the distance between x and 4 has to be less than 6. Okay, well, this means that x has to be closer to 4 than 6 units. Can't be 6 units or more away from 4. How can that happen? Well, it turns out that, first of all, x minus 4 has to be less than 6. Okay? Because if x minus 4 is greater than 6, this means the distance between x and 4 is more than 6. Or even if it's equal to 6, that's not less than, right? Okay, so, and this says that x has to be less than 10. Okay, but there are plenty of numbers less than 10 for which the absolute value of x minus 4 is not less than 6. Like negative 350. Just a number popped into the top of my head. Okay? If x is negative 350, then the absolute value of x minus 4 is certainly not less than 6. So you got to have some lower limit on what these numbers can be. If they get too far in the negative direction, it's not going to work. So it also has to be that x minus 4 is greater than negative 6. Okay, which means, of course, solving this, that x has to be greater than negative 2. Now, x has to satisfy both conditions. If it doesn't satisfy this condition, then it's 6 or more units from 4. If x doesn't satisfy this condition, it's 6 or more units from 4. Okay? Now, we combine these two to say negative 2 less than x less than 10. Okay? Now, we can also have done this using a number line without any algebra or anything to see if it's consistent. Okay? We're saying that the distance between, that x is closer to 4 than 6 units. Okay, the distance from x to 4 can't be 6 or greater. So we have 4 and we go 6 units from 4 to this number, whatever it is. Okay? And of course we can count. Now if we go 6 units, we're at 4, we got 5, 6, 9, 10. And you see that agrees with what we have here. X can't go this far. It can go any distance up to this far from 4 and still be distance less than 6, right? But if it goes to this point, the distance is 6, it's not less than 6. And if it goes beyond this point, the distance is greater than 6. So on this side of 4, you can only go up to here. Now if you go 6 units on the other side, well, you go down to what? 4, then you go 3, 2, 1, that's 3 units. 0, negative 1, negative 2, that makes 6 units, and we're at x equals negative 2. And x can't go this far, but x can be anything in between. So we can even graph this, and this is very straightforward. Right there's the interval that corresponds to this statement that x is within 6 units of 4, but not 6 units away. Okay, less than 6 units away. And this, of course, is just a graph of this inequality. Okay, now contrast this with this statement, x plus 2 greater than 8. Now you want to stop and think about what that means in terms of distances. See if you got it right, see if you're thinking correctly. But I'm just going to say, this says the distance between x and negative 2 is, I got an LT there, which would stand for less than. Should have been a G for greater than. Is greater than 8. Okay? This between x and negative 2 is more than 8. That's what this is saying. Because absolute value of x plus 2 is the absolute value of x minus negative 2, and x minus negative 2 is displacement from negative 2 to x. Okay? And the distance being the absolute value of the displacement. Well, we talked about that earlier. Make sure you've got that locked in. So, in other words, x has to be further from negative 2 than 8 units. Okay? Now, if we do it on a graph, we start at negative 2. We count 8 units in this direction. And wherever we end up, x has to be further away than that, so that the solutions on this side are from here on, but not including this point. Now, what's this point? Well, we got 8 units. Starting from negative 2, we got negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. 8, yeah. Wait a minute. That made no sense. Again, negative 2, we got to count 8 units. Okay, so we get negative 1, 0, 1, 2, that's 4 of them. And then 3, 4, 5, 6. That's 8 units. So why do I have all these marks? That's more than 8 marks. I got carried away making marks, obviously. 6 should be here. Let's correct this. The idea is correct. The execution left something to be desired. Okay, 6 is here. Negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. So, x has to be further than this from negative 2, which means it's out here. Now, if we count 6 in the opposite direction, hopefully I got 6 marks this time. Wait a minute. Yeah, that's right. Okay. 1, 2, 3, 4, 5, 6, 7, 8 marks. Here apparently I had 10 marks. I must have lost count. Must have been thinking about something. That probably wasn't it. Okay, negative 2. We go 8 marks. That's negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So, x has to be on this side of negative 10. You know, if you're on this side of negative 2, you have to be beyond negative 10. If you're on this side of negative 2, you got to be past 6. And if so, your distance between negative 2 and x is then greater than 8. Okay. Now, we can do it algebraically, and the way we write this algebraically, over here, a less than said, well, this thing has to be less than 6, and it has to be greater than negative 6. Okay? Here, what we're saying is that x plus 2, your displacement, or whatever, it has to be greater than 8. That would correspond to this. Or it has to be less than negative 8. Okay? Yeah. Now this is an or because it can't be both. If x plus 2 is greater than 8, then you're out here and you have a solution. You have a point x that's more than 8 units away from negative 2. If x plus 2 is less than negative 8, then your displacement is less than negative 8, meaning your distance is greater than 8. Okay? So this is how we